All right, welcome back. Let us finish up this review set of slides. So we stopped down here on for. So we're talking about for loops, and what they do is they go through a list. Okay, a list or something list-like ranges. And so what it does is it goes through this list L, call it, and then it sets each value one at a time in order from left to right to some variable that you set, okay, that you give a name for, like x, for x and L maybe. And as long as there's a next element, this variable keeps getting set to it, and the body gets executed with variable holding that value, okay? So that's the kind of loop that for loops give you. So let's talk about this with examples. So let's find the min of a bunch of values in a list that we get from the user, okay? So let's do a few things. I've made a for.py file. The first thing that we need to do is get a list from the user. So let me get that really quick. So get a list from the user, and then we'll get the min of the list. And that should be the order in which we do this. So let's call our list L, and it should start out empty, right? It should start out as an empty list, and we can do what we were doing last time by getting a bunch of numbers until the user types -1. That could be how we fill this list, maybe. That would work. We could say while true, input, enter the next number, and let's pretend that the user's typing ints, and we could set this to, I don't know, just call it num, and we then need to add it to the list L. L equals whatever it was plus this new list with just num in it. Put that at the end, please. So it makes a one bigger list. And we want to do this as long as num is not -1. So the second it is, break, so that we're done. Okay, so now we have the list. Now that we're down here, we have the list. We have the list called L. We can print it out just to confirm that we have it. 1, 2, 3, -1, and we have the list 1, 2, 3. Okay? Now, let's go and get the min of that list using a for loop, right? It'll iterate through the list L. So the idea for minimums is you have to make a guess, because you don't know what the list holds, right? If the list holds, I don't know, 3, 1, 2, we're not sure, because the list is kind of like a black box to us. We're not sure what's in there yet until we look at it. So the minimum, if we could, we'd have to start it at like positive infinity or something. But that's not very easy to do. So what we do instead is we just say, we just make a guess. We say that, okay, our idea of the min is whatever the first value is, L of 0. Okay, this is L. We're going to set the min to initially be 3 in this case. And the idea is we're going to go through every element of the list and see if we ever find one smaller. Okay, and that's how we'll keep replacing it when it's smaller. Okay? That's the idea. We'll just keep on updating our guess for the min, and once we get through the whole list, updating the guess as needed, it will have been the real min. Okay? And that's better than starting like the min at 0 or something when there is no 0. Like, that is not a real min. Okay? So the number that you start it with is a number that's actually in the list. That's the key. Okay? That's why that works. So here's the idea. Min guess. It starts as L of 0, okay? Initial guess is the first element of the list. And then we go through the rest of the list. Updating the guess as needed. Okay, so for, we can just call it x in L. We want to iterate through the rest of the list, so we could say, starting at index 1, go to the end. That would work. Or you can just go through all of L, okay? That would work. We could just say, iterate through the list. Because you won't reset the guess for the first element. It doesn't really matter, though. Okay, so we're going to go through every element of L, call that element x one at a time, and we're going to see if our guess needs to be updated. So if, how do we know that we found a number that's closer to our minimum, something that's better of a guess than our current one. Well, we just found a smaller number. If x is smaller than min guess, then min guess better have been x, because that is smaller than the one we have in there. That's closer to the real minimum, if not the real minimum. Okay, see how that's working? And so that's all. That's all you have to do. And then at the very end, it holds the real minimum. The min is, drumroll please, it's min guess. Because now the guess is correct. Once we've gone through the entire list, finding the smaller and smaller number. Okay, that's the idea. Hopefully that makes sense. Please yell at me if it's not. This is exactly the kind of stuff I want you to yell at me about in office hours. So 3, 1, 2, -1. So our guess starts out being 3. Then we change it to 1 because we see x being 1 in the next iteration. And then finally, 2 doesn't really change anything. It's not smaller than our current guess of the min, which is 1. Okay? So the min is 1, and we are happy. That's the idea. So that's one example of for loops. I just iterate through something like a list. Let's then prove this statement is true. Let's prove that there exists an x that's between 32 and 37, and it's prime. Okay, so we gotta actually maybe take a second to understand how you might go through, how you might maybe use a loop to figure out if this statement is true or false. Okay, think about that, and then I'll talk about how I will do it. So the idea is to prove that this is correct, to prove that there is some x for which all this stuff holds. Let's just iterate through all these x's, 32 through 37, and check if any of them are prime. That'll do it, right? Oops. So one thing that we can do is make use of ranges. A range between 32 and, I'm going to go one more, so 38 will give us those numbers. See, that goes 32 to 37. So if we iterate through this range, I think we are in business. So we can say, this is like the next part, example 2. So for, I don't know, let's call it for y in range. Why not? So we're trying all the numbers between 32 and 38, and we're trying to prove the theorem, okay? We're trying to see if somebody is prime. You see that? So is true equals false right now, or maybe like theorem is proved. Found a proof. We haven't found one yet, but we're going to go through all the valid numbers and see if any of them are prime, and if we have found one, then we found a proof. If is prime, let's make a function called is prime y, then found a proof equals true, okay? And we can say print the proof, the statement is found a proof, either true or false. Isn't that cool? So just go through all the numbers, see if any of them are prime. If so, you've found a proof. Otherwise, the found a proof stays false, and we haven't proven anything. Yeah? That is how you would prove this statement. It's just looking for some x. There exists some x somewhere within this range, and it's prime. Okay? So we'll make an is prime function very quick, but we'll talk about functions more on the next slide. We just need it this time. Def is prime. To see if a number x is prime, you go through all the numbers. Well, the most naive way of doing it is to go through all the numbers for, I don't know, n in range between 2 and x minus 1, so not including x, and see if any of them are divisible, if any of them cleanly divide into x. Okay? If that's true, if n cleanly divides into x mod n, that's 0. If the remainder is 0, then we found a divisor, something that we found a factor, so we can return false, because that's obviously not a prime number at that point. Otherwise, if we make it through this loop, we return true, and the number was prime after all. Okay, that's an easy way to discover if a number is prime. It's quite inefficient for large numbers, though. So that's the idea, and so let's try it. Oh, I gotta do this first. 3, 1, 2, -1. Cool. And then the statement is true. Okay, statement is true because it found a number. I don't know, let's print the number that it finds. Print y. -1. No, 1, -1. How about that? it found 37. 37 was the first prime, apparently. 32 all the way to 36. None of those were prime, but 37 was. So it is true. Okay, so that's how it's working. And that is for loops in a nutshell. So please, hopefully this little cheat sheet is helpful. And it's telling you how all of this this code gets executed. Okay, so now it's time for functions, and let's talk about them. So my example is going to be a rot13 function. So we're going to do that cool cryptography stuff where we're going to replace A's with N's and B's with O's and all that stuff. Okay, that is the idea. And so hello is going to get translated into uryb. And the beauty about rot13 is because there's 26 letters in the alphabet, you do it again, you do rot13 one more time to the uryb, it makes it become hello once more. Okay, so let's see here. What do I want to do? Let's do this one with functions. So the idea of functions is you define them with def, you give them a name, you give them all the parameters that they need to like do stuff, and then you give a body, which gets executed with parameters holding values. And sometimes your function needs to return something. Sometimes it just needs to do something. Okay? So keep all that in mind. And then once you have a function, you can call it. You can give it real values, arg1 for param1, arg2 for param2, so that when the body gets executed, these values are being used for those. And potentially, you might give back an answer, so you might need to save that answer somewhere. Okay? So remember to save that result, or just use it when it returns a value. Otherwise, there is no real point in calling it, right? So let's make a rot13 function that encrypts a string that the user gives us. All right, so let's do that. Let's make a new file, call it rot13.py, and let us begin. So we want to make a function. We want it to be like this. We want it to be like print rot13 of hello. Okay, and once it's done, we want it to have given us back that uryb. Okay, so to make a function, we have to say def rot13, and we want it to give us to be given some string s maybe. So s will be equal to hello, and I call it. Okay, and so now our job is to implement this. If we see an A, we make it an N. If we see an N, we make it an A. Okay, and so we have to like look up. We could have a big long if else table if we wanted to implement this. But there's a slightly easier way of doing this. What we can do is we'll make a list. Make two lists: chars and encrypted chars. Okay, and we'll use them. So normal chars is A, B, C, all the way to the end. So ... I'm going to fill that in. I'm going to pause and fill this in. And then encrypted chars equals whatever we want to give back for the A, for the B, for the C, in order. Okay, that's the key. And so for the A, we want to give back N. For the B, we want to give back O. Okay? That's the name of the game. And so I'm going to fill all this in with this table, and I'll be right back. Okay, I have returned, and so here is our table. Here is, let's get that out of the way. Here is chars. For A, we give back N. For B, we give back O. For C, we give back P. And it all wraps around, so once we get to N, it starts giving back A, right? N gives back A, and these are all at the same index. O gives back B. So I've made it like this. Chars ... and then encrypted chars. And it'll look like this. So at the same index, I have, here's the A, then I have what I want it to be translated into, to N, at index 0. At B, same index, index 1, I put the O, okay? And then at C, I put the P. Okay? That is the idea. And what we have to do now in order to encrypt is go through each character of S, which we could use actually a for loop for. So go through each character of S, and we're going to build up a result string, okay? Encrypted string equals empty to begin with. We're going to go through each character, and here's what we're going to do. For C in S, for each character C in S, we're going to find the character in this table, okay? We're going to go to its index and find it there. Are you ready? So we have to search for it. And you know what? This might be very difficult. So I think a better way to do this is to split this up into encrypt a whole string and encrypt a single character. And so we can call the encrypt a character from our encrypt the string function. Okay? That is my plan. And then one of those has this. Okay, I think that's a better idea here. So let's do, let's split this up a little bit. This will be encrypt a character. Okay? Let's have it be like this. Encrypt a single character C. And then we'll have def rot 13 that actually encrypts a whole string. Okay? Then here's what we can do. We can build up the result, again, start out being empty. For each character C in the string, we're going to encrypt that one character, yeah, and then add it to our result. That will make this whole thing a whole bunch easier on us. Okay, so that should make it very nice. Okay, and then we'll just return the result back once we're done. Okay, so that should make this much easier. And then for the single character, we need to figure out which C this is, which character this is, look it up in our chars table, and then go to the same index in encrypted chars. Okay, so find index of C in chars. So here's what we'll do. We'll be like, for, I don't know, I guess I'll have to call it x in chars because I'm already using a variable C. If x is equal to C, then I want to save that index, okay? Let's start at -1, something that's impossible. Then we have, let's see here. If x is equal to C, then, oh, sorry, no, this isn't going to work because I need to save the index. So I need to go through, I need to use indices. For I in range len of chars. So I'm going to go through, let I go through every valid index in the characters list, and we'll see if chars of I is equal to this character C that was passed to us. Like maybe the user gave us C, we want to give back P. So we want to get the index 2. So we can go to the same index 2 over here in encrypted chars. Okay? That's the idea. And here's what we'll do. We'll just return encrypted chars of IDX. We save that index. That's the idea. If it happened to be -1 at the end of all this, then the user gave us maybe a lowercase character, a number, something that wasn't in our list here. And it's up to you how you want to handle that, but I'm just going to let it return Z or something, because -1 is the last index if you use it that way. So that's how that should work. So encrypt a single character, and then encrypt an entire string, and let's see if we get back uryb. Char is not defined. Oh, what have I done wrong here? Oh, sorry. It's chars of I. Hey, we get uryb. And if we do it back, if we rot 13 the rot 13, what do you know? We get hello back. Isn't that cool? So that's functions. And yeah, lots of examples today. So I have 3 real slides left, and then I'll just show you some cool stuff. So we should talk about randomness. There's a lot of libraries in Python, and there's math, Math's a fun one. We'll look at that one for nice things. Then there's random. Okay, we've been using random a bit for our programming assignments. And usually, we just want to get a random integer between a certain range, and we've been using randint a whole lot. Okay, that's possible. So I think that's what we can do here. I have two random examples. The first is Randomnetchasketch with turtles, and so we'll have the turtle draw a bunch of random lines and turn in random directions. So we'll have the turtle like start here, and then he can start where he normally starts. And we'll just have him draw random length lines and then turn in random directions. And so it'll just be like an Etch-a-Sketch. That'll be cool, huh? So, and then maybe we should stop drawing when the turtle finally goes outside his rectangle. Okay, so let's do that one, Etch-a-Sketch. I'll call it etch-a-sketch.py. And please yell at me if any of this stuff is not making sense. These are kind of complicated examples, but they should be fun though. So random Etch-a-Sketch, here's what we'll do. Import turtle, and we're going to use random a whole lot. So import random2. And so we're going to forever, while the turtle is within a 600 by 600 rectangle. So I don't know, while turtle.getX, I think. Where is that? Is it getX? Let's make sure. Exactly. Turtle position, x-core. It's x-core. Okay. X-core needs to be between -300 and 300. And same with y-core. So while that's true, we'll keep doing cool stuff with the turtle. Otherwise, he's gone out of bounds. We stop him. Okay? So while this is all true, we're going to pick a random location for the turtle to go. Okay? So we're going to... How about we draw a line first of a random length, and then we'll pick a random location. So random length equals random.randint. Let's make a length go between, like, I don't know, 10 and 150. Why not? And then we'll have a random direction, random angle. Let's do it as, let's make a choice, okay? Let's make him only turn at right angles. So we'll say random.choice to return a random value between a list, inside of a list. So please, random.choice, get a value between 0, choosing from 0, 90, 180, and 270. Okay, and we'll turn the turtle based on this. Okay, that'll do it. We can turn them left or right, it doesn't really matter because it's random anyway. So let's just stick to left maybe. And so we'll move the turtle forward by that length. And then we'll turn in the random direction. Okay, so we'll just say turtle.forward, random length, and then turn in a random direction, and it will make some cool stuff for us. Turtle.left, random angle. Okay, so just this, very short program. It should do some cool stuff. Look at him go, and then he ran out of the room. He got out of the bounds. Let's see if he'll go a bit farther next time. There he goes, and then he goes out of bounds. Darn. You could play with all these numbers to keep him within certain bounds, like, oh, you can only go between 10 and 50 now. And so now he stays up in here for a bit longer. Look at him move around, making random maze-like structures. Isn't that cool? It's all very pretty. And on average, I mean, if you do the stats, right, he's going to want to stay towards the center. And so this might take a while for him to finish. But the second he tries to go out of bounds, and he looks like he's trying to, we're going to send him, we're going to stop him. Okay? So we made a very cool abstract piece of art thanks to the turtle in randomness. Isn't that nice? So that's my first one, my first example. And then I have another one. Let's approximate pi by throwing darts. This one's going to be weird, but it's really, really cool. So here's what we'll do. we are going to make a little square in our minds, and this is not going to be turtle based, it's just going to be in our minds, and then we're going to circumscribe that circle, or that square, just like that. We're going to draw a circle inside of it, and we're going to pretend that this is a unit circle. So that's 1. And so the side length of this perfect square is 2 by 2, okay? With a radius 1 circle sitting inside of it. And here's what we're going to do. We're going to randomly pick coordinates, okay? Because we can pretend this is 0, 0. Randomly pick coordinates and throw darts. Each coordinate's going to be a dart throw. It's like, bam, I threw a dart there. 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 And each time I throw a dart, I'm going to keep track of, was it inside of the circle, or was it in the part that's outside of the circle? Okay? It just so happens that if you do this, you randomly pick these points, you randomly throw these darts, the number of darts that are inside the circle versus the total number of darts, if you divide those, it's going to approximate pi over 4. Isn't that crazy? Isn't that weird? So the idea is throwing these darts approximates area. Like a single dart is like a piece of area, right? And so what's the area of this circle? It's pi times 1 squared. So pi times 1 squared, which is just pi. And then what's the total area of the whole rectangle? Sorry, the whole square. It's 2 by 2, which is 4. So the ratio of darts that hit inside the circle versus total darts is pi over 4. If we multiply that by 4, we get pi. It's crazy. It's so cool. So let me show you how to do this. Random dart throwing. Okay? Dun dun dun. And so I guess let's make a new file. I'll say darts.py. And here's what we do. We just want random. And let's do this 1,000,000 times. Okay? For I in range 1,000,000. We're going to do this 1,000,000 times. Throw 1,000,000 darts. What I want to do is throw a dart between, like, this is -1, -1, and 1, 1. So I need to pick an x value between -1 and 1, and a y value between -1 and 1. Okay? And that will be my dart throw. Okay? X equals, and now I need a random number between -1 and 1 that is floating point. That's a float. Okay? So now I have to do different things. I can't say rand int anymore. I have to say, let's see here. Not sample, I think. Yeah, here we go. I have to say uniform. Random.uniform between -1 and 1. Yeah, that'll work. So I do that one. Oops. There we go. And then y gets a random y coordinate. And then this is my dart. Okay? X comma y represents 1 throw of a dart. And then I keep track of how many of these darts landed inside the circle. Starts at 0, of course. So I need to see if I'm inside the circle. Then I'll say darts inside circle gets 1 more value. Okay, so how do we keep track of whether or not this dart throw, this xy coordinate, was inside of our unit circle? And that's where math comes into play. How do you know that this was inside the circle? Well, x squared plus y squared will be less than or equal to 1 in that case. You see that? That's the equation for this circle, for this unit circle, isn't it? For the whole thing. Equals 1 is like the circle itself, but I guess the disk is less than or equal to 1. Yeah? So that's all we have to do. So if, or we can make a variable called inside the circle. Make it be true or false. Isn't this fun? We are solving problems together. So inside the circle, you're inside the circle if x squared plus y squared is less than or equal to 1. Yeah? And this is just a Boolean variable. It's either true or false. If it's true, we're going to add 1 to our number of darts that we hit the circle in. Isn't that fun? And then we just print this ratio, the number of darts that hit inside the circle over the total darts, and then multiply it by 4. Isn't that crazy? It blows my mind still. Okay, so darts inside circle divided by 1,000,000. So that's the total number of darts we threw times 4. Drum roll, please. Whee! 3.139. It's very, it's not that efficient. It's not that accurate even with 1,000,000 throws, but it's still cool. Let's try maybe 10,000,000. Let's do an extra. Dun dun dun. So throw 10,000,000 darts. Takes a while. Take 10 times as long as it was before. But it should be a little bit more accurate. Hey, that's quite close. It's almost, that's 3 decimal places, right? Because it's 3.1415. Nice. It did it. So you might get lucky for just 1,000,000 anyway. But that is calculating pi by throwing darts. Okay? All of these are just little examples of problems. They're kind of difficult, so I'm not going to ask you to throw darts on a test, but it's all just getting examples in, getting practice with Python. Okay? So I have 2 more slides, and they're all about target, because when I went to UCSB, there wasn't a target for 5 years when I was a PhD student there. Only in my last year there did they finally build a target, and we were all so happy. So I will pay homage to that by making a lot of target logos. So let's make a target logo that is perfectly square, okay? And we're going to use functions for this. How we solve problems is usually using functions. So here's what we'll do. We will draw the outer square, color it in completely red, and then we can draw a white square right here. And that will counteract this filled inness. You see that? Draw a white square, there's a red square, there's a white square, and then again we'll draw a red square inside the white square. Isn't that cool? That's the key. Okay? So we'll make this draw square function. Draw square, center, width, and color. I'll need both of those. This is target rect.py. Here we go, here we go. So we're going to make this function. Draw a square with a certain center, with a certain width, with a certain color. And so here's what we'll do. We will set the fill color of the turtle. And I think it's just set fill, right? Or is it fill color? Yeah, it's fill color, sorry. That's why we look it up. Set fill color to the color we pass along, and then we want to draw a square with a certain center, and then a width, and a color. So, yeah, let's do it this way. So the center should always be 0, 0 when we draw our target logo. So we should be draw square, 0, 0 always, and then with a certain width, I don't know. Are these a thirds? I don't know. This could be, I can't quite remember what I was doing here. That looks a bit fancy, doesn't it? We'll figure it out. We'll figure it out together. But maybe this can be, I don't know, 200? I think 200 is valid. And so if that is what we want, if it is 200, then given this center, we want to go out and up by half of that width, okay? Because that's 100, that's 100, yeah? So we need half of that. And we need to move the turtle to that location, okay? So our real starting location is, if this is center X, center Y, that's a horribly drawn center, I'm sorry. If this is the coordinate where we want to start drawing this square, the coordinate where we want to, like, we started here. The coordinate where we want to actually put the turtle to actually draw the rectangle is go left and go up a little bit by half of that. Okay, so it's really going to be center x minus width over 2, center y plus width over 2. Okay, so that's our starting coordinate. Then we can just draw a square as we know how. Okay, I think that should work. So turtle.up, turtle.goto, if this is center, center x, center y equals center, then we're going to go to center x minus width over 2, center y plus width over 2. And then we're going to set our fill color. We're going to say turtle dot begin fill, and then draw our rectangle, and also remember to do turtle dot end fill as well. Okay, so now all we have to do is draw the actual square. So turtle dot heading, make him face east, and then we're off to the races. Okay, turtle dot forward by width, and then turtle dot, I guess we're turning right this time, right by 90. And if we do that 4 times, we will have drawn a square, I believe. So let's see if that works, and see if we need to change anything. So start at 0, 0, draw a 200 size square in red, please. Oh no, heading takes 0 positional arguments. Oh, sorry, it's set heading of 0. Excuse me. Yay, we have a red rectangle. That's looking good. Now we need to draw a white. A nice white square as well. So still 0, 0, but slightly smaller. Okay? So like this will be 150, and it'll be white. There's that one, there's that one. And so maybe it should be 100 instead. We'll come up with the right numbers eventually. That's looking good. That might be too much, actually. How about 125? And then the last red one can be maybe 75, I don't know. We'll see if that's looking good. Yeah. Oh, this wasn't enough, was it? That's minus 75? What's 125 minus 75? Is that just 50? So yeah, we're just drawing a bunch of squares. That looks good to me. Isn't that nice? So that is how we draw our target logo. We can make it bigger if we want to, just change these, multiply them by a certain amount. But I'm good with this. Now, let's do a circular target logo, okay? And then you can try maybe a triangle yourself. So what I want to do is show you all this. Maybe I should make a new file, call it target circle. Instead of draw square, we can make draw circle. That's fine. That's easy. Center, width, and color. And there's actually a draw a circle in Turtle Graphics. You just say turtle.circle. Okay, you give it a radius, and that'll do it. Okay, that is what you do. So I can't remember where you need to start the turtle when you do this, so we're going to figure that out together. Turtle.circle, draw a circle with a certain center, and then we'll say turtle.circle maybe, with a certain radius. We give it a radius this time instead of a width. Okay, so let's see what this does right now. Draw a circle, draw a circle, draw a circle. I think it might be off a little bit based on how it draws that circle. Name width is not defined. Oops, sorry. I don't think we need this line right now anyway. There he goes. So, okay, yeah, that's what happens. It looks like he needs to be moved up a little bit. That's a cool looking logo, though. So the center is off. The turtle, apparently, given where he starts, he draws a circle. That's his bottom. So we need to move him up a little bit, okay? So if this is where we want the center of the circle to be, we need to move the turtle down vertically by the radius, okay? Move the turtle down vertically by the radius, and that should fix it. So turtle.goTo, keep your same x, but reduce your y by the radius. That might help. Yeah. That's looking very good. Now we have a target logo. Isn't that nice? So, the idea is we had two target logos, right? We had draw rectangle version and draw circle version. Yeah? We can make a draw target logo kind of function, okay? Here's what you can do. Draw a circle. This was all the same, right? We used all the same parameters. We just used draw square instead of draw circle for the rectangular target logo, right? All the same parameters and everything. The only difference was this function that we used. So let's make a generic version of this target logo drawing function. Let's make a function that's like draw target logo with certain shape. Something like that. Draw generic target logo. We will take our drawing function as a parameter. That'll be interesting, won't it? Dun dun dun. So, instead of this or that, let's do this. Let's make a def draw target logo with a certain draw function and then a certain like width, okay? With a certain width. That should do it. That should do it because we'll just give it the function that we want it to use, right? That is all we need to do. So, or this can be just like size or something generic. Because then, all that we have to do is not draw square anymore. It's not draw circle anymore. It's draw func. Whatever we passed, just call it. That's all we want to do. Isn't that cool? So instead of any of this, instead of that, instead of the above, here's what we can do now. And I'm sorry, it looks like Python, the program is not making anything pretty anymore with nice colors. Instead of the above, we can now do draw target logo with our draw circle function and a certain size, right? We can say 200, or I guess we can say 100 for the circle-based version to keep it the same size as the other one. And it's just going to use this function. It's going to pass along the function to this function. And so instead of draw a func, it's being passed along draw a circle. And it makes the target logo that way. You can do that, or just as easily, you can do draw target logo with draw square. Isn't that cool? So let's comment out that one so it only does the square version. Just as easily, it works. Yeah? And then maybe we can make this one 200. So now they're both the same size. Yeah. Isn't that nice? So, yeah, I think that's where I want to stop for these. Draw target logo. Let's keep the circle version, and the square one can be commented out. But hopefully this makes sense. You can make a function that takes another function as a parameter, and it kind of makes this process that we're trying to do here more generic. And so if you had to draw a triangle function now that worked the same way, you could just as easily draw a target logo out of triangles. Isn't that cool? So that is officially all that I want to do in blowing your minds, getting you back up to speed with Python to look at, stare at this cheat sheet and ask me any questions that you have. There are some cool examples that there was just no time for in the class, but that I made before. So let me show you those if you want to look at very long Python programs. If you're interested in like getting better as a programmer, it might be useful to look at these programs. So I made one that draws like Pete Mondrian style artwork. So it draws a bunch of rectangles in random spots. It's quite complicated, but let me kind of show you how it's working. I'm going to show it to you. Might as well run it first. Let's do open. Whee! There it goes. And I want it to, that's its little scaffold. And now I can keep typing enter, and it's going to keep on drawing random things. And eventually, it'll get to a spot where we're happy. That looks like a good piece of art, so we're done. Okay. Cue to quit. There we go. There's our artwork. Okay. So, let me show you how this is all working, how I'm making this as a program. So first, I make the turtle draw really thick lines, and then I draw a bunch of random, I draw a bunch of random straight lines, because those are where these eventual squares and rectangles will overlap, okay? They will start from a certain corner, go to another corner, and that is their square, okay? So I get a bunch of horizontal and vertical lines to make these rectangles. Those are like the scaffold, and so I draw a bunch of these random lines. And then repeatedly, I pick 2 horizontal lines and 2 vertical lines, and those will represent the bounds of the next rectangle that I want to draw. Isn't that cool? And then you just draw a bunch of rectangles, okay? All you need is a big long draw rectangle function that picks a random color. But yeah, that's what this is doing. Take a look at it and see if you can recreate it. That's the first example. And then finally, in my last cool example, you know that Joy Division album that everybody wears as a t-shirt? We can make this in code, actually. We can use the turtle to draw this exact pattern, because this pattern, I don't know how much of a Joy Division fan you are, but this pattern comes from a, I think you pronounce it as quasar or something like that. It's one of those celestial objects that emits radiation. Somebody just pointed an antenna at it one day in the 70s and took this reading. Okay, it's pulsing. It's a pulse. Maybe it's a pulsar. I'm not sure. And so that's the information that it gets. That's quite nice. So we can draw that. Okay. And here's the code to do that. Of course, I'm going to give this to you. Feel free to look at it. It's just a fun little example. And so here's that signal. So yeah, okay, it was a pulsar. And it was the oscillation signal coming from it. And here it was, all of these offsets from 0. So these are each individual lines, a list of lists. And then we have a bunch of draw rectangles, draw polygons this time, because we have to like go up and down and left and right. It's going to look weird. And then a bunch of draw lines. And I won't try to explain all of this, but ask me about it if you'd like me to go over it. It's very fun. We make our drawing space, and we make sure that we are drawing a bunch of lines evenly spaced. And then for each signal, we draw a line between each little signal location, okay? Each different reading that has been taken. So, without any further ado, I have to slow down the turtle a whole lot to get here, but this is him drawing the cool Joy Division logo, and the best part about this is that instead of like the t-shirt where it looks like this, you get it to look like this, and you have a turtle in the view. It'll be at the bottom right. So I think that makes it even better. Okay? So that officially is all I have to show you for the review. That is all the Python that I wanted to go over. Please ask me any questions that you have. If you're wondering about anything at all, we will make it make sense, and we can talk about it there. So there is our, oh, it's almost done. It's getting there. You can do it, little turtle. There he goes. And so it's exactly the same, because it was the same information. And we get a turtle on the bottom right. Isn't that fun? So that is the end. Good luck on the final. Let me know if you have any questions, as usual. And kind of the whole point of this class is to get you to want to be a computer science major. So if any of this that we have been doing in this class sounds fun to you to do as maybe a career, talk to me and consider becoming a computer science major. So that is officially all that I have for you. That is officially all of the lectures in this class, and I will see you during the final.